All right, hey guys, let's take a look at 1.3 part 2. So we're looking at end behavior. The end behavior of a function's graph is the behavior of the y values as the x values approach positive infinity or negative infinity. All right, so let's see visually what that means. So we're going to look at your leading coefficient, which we talked about in the last lesson. That is the first coefficient. It's the coefficient of your highest exponent, a couple different ways to look at it. But if your leading coefficient is a positive, it could have two things. It could be like a positive, like 5, right? With a degree that's odd. So if I have a degree that's odd, your degree is your highest exponent. So maybe I've got like x to the odd number. So x to the 7th, sure. That means it is going to turn a bunch of times in the middle, but the end behavior, what happens to negative infinity, like all the way to the left, is it's going to be going down on the left, like down to negative infinity. On the right side, it would be going up to positive infinity. Now this could turn, a bunch of times. All right, so maybe it turns, 6 different times, sure. But we're talking about the end behavior. And the end behavior for this, I wanted some space to write this. Let's see, I'll put this over here. So what if it goes like this? Okay, here's how I'm going to write it. As x, actually I'll put it like this. My y's go toward positive infinity, like my y values up and down. My y's are going up as the x's go to positive infinity, like to the right. Basically, this is saying my graph is going up as I go to the right. That's describing like that right side end. Let's describe the left end. Okay, so that left end, I think that's going down. So my y's are going to negative infinity as my x's are going to negative infinity as well. Like as I'm going to the left, this pretty much means I'm going down as I go to the left. Is pretty much what that means. Okay. So yeah, here I'll try to put this in words as well. Y going to positive infinity, my y's are going up. Basically, yeah, the word up. As x goes to infinity means as I go to the right. I'm going up as I go to the right, and I'm going, y values go up and down. My y values are going down as I go to the left. So if you want it in words, that's basically what it's saying in words. Okay, so what if I stick with a positive leading coefficient, like this positive 5 here? What if I stick with a positive 5, but I'll have an even degree this time. So maybe I've got like x to the 4th or something like that. So I'll put this in another color. If I have a 5x to the 4th, both ends are going to go in the same way. They're both going to go up. It might turn a few times in there, sure, but both ends are going up. So this means that my y's are going to infinity. Again, y to infinity means up. As my x's are going to infinity, like as I go to the right, I'm going up to the right. And y's are going toward positive infinity this time. Like I'm going up as x goes to negative infinity. Like I'm going up on the left side as well, this guy right here. So again, I'll just write this in words. This means I'm going up on the right side, and I'm going up also on the left side. These are my ends, like the arrows. They're going up on the right side and up on the left side. All right. If I have a negative leading coefficient, so maybe I've got, I don't know, a negative 5, x to the 7th. It still has an odd exponent here. It's still a 7 is odd. But I've got that negative leading coefficient. in which case it's going to do pretty much the exact opposite. It's going to go up on the left and down on the right. It can still turn a bunch in there. I can turn 1, 2, 3, 4, 5, 6 times, whatever. But this is still going to be my end behavior. The ends right here. The y is going to negative infinity, like it's going down. As my x goes to positive infinity, like on the right, it's going down on the right. Now let's describe the left side. Y is going to positive infinity, like it's going up, as x goes to negative infinity, goes up on the left, is basically what this is saying. Okay, so this, yeah, y values go up and down. This is going down on the right and up to positive infinity on the left. Okay, so that all depends on your degree and leading coefficient. All right, last but not least here, let's look at if you have a even degree with a negative leading coefficient. So even degree, like I had a even number of 4. So maybe I've got x to the 4th again. There's an even degree. Negative leading coefficient. So that's what I multiplied in front. If I put a -5 in front there. All right. So this would be something like, you know, it kind of turns a few times, but both are actually facing down now. So let's see how to write that. So y goes to negative infinity, like I go down, as my x goes to positive infinity. I go down on the right side. And then y goes to negative infinity, like I go down, as x goes to negative infinity, like on the left side. I'm going to go down on the right side and down on the left. Again, keep in mind your y's are the ones that go either up or down. Your x's either go right or left. So this is saying I go down to the right and down to the left. All right, so these are all the possibilities here. So we're going to describe the end behavior of the graph of my negative 0.5 x to the 4th plus 2.5 x squared plus x plus -1. So this guy right here. And really what I care about is the leading coefficient, like on my highest exponent. So it says highest exponent. The highest exponent itself is a 4, and the leading coefficient is multiplied in front of that. So this is a degree 4. Let's see. Degree 4, which 4 is degree. 4 is even, so I got to be in this category, one of those two guys. And I've got that negative 0.5. I've got a negative leading coefficient. All right, so that guy, which means here's my negative section. So that means it narrows me down to this guy. We don't put in that color. Here's this guy. My end behavior, pretty much I'm just going to write what it says here. Y goes toward negative infinity as x goes toward positive infinity. And so that describes the right side. This basically describes right side goes down. Let's see, I'm running out of space here. So yeah, it's pretty much saying the right side goes down, and then I got to describe the left side. So the left side, again, I'm writing this just the way I did before. The left side also goes down. So y values have to do with going up or down. Both of those are going to negative infinity. They're both going down. And then, so this is saying left goes down. Left side goes down also. All right, so there's the end behavior, the two ends of my graph. So let's do the end behavior on this guy. This one has, let's get the degree and the leading coefficient. The degree of 3, highest exponent is 3. The leading coefficient, the number multiplied in front of that x to the 3rd. is a positive 0.25. Honestly, I don't care if it's a decimal or whatever. I just cared if it was positive or negative. So I have a positive leading coefficient with a degree of 3. So 3 is an odd number. Okay, all right. So it looks like that matches up with this section of my chart here. Stuff that I had in black here. So this means that I'm pretty much write exactly what I have at the bottom here. Y goes toward infinity as x goes toward infinity. Basically means I'm going up, or sorry, I will go up, but this means the right side goes up. And then the second part, I'm going to again write the same thing that I had before. Y goes to negative infinity as x goes toward negative infinity, meaning that the left side, as x goes to negative infinity, that's my left side. So my left side goes down, is what this is saying. Okay. All right, so different books use the infinity and negative infinity. Others use the up and down, left and right kind of thing. But there's a couple different ways to say the same thing. All right, and then this one, they gave us a graph. So use each graph to describe the degree and the leading coefficient. So I do notice on the right side here, right side goes up, and the left side, it looks like, the left side is going down. All right, so let's use that to give me the degree and the leading coefficient. This would be, here, I'll put it over here. The leading coefficient okay, so here's my description. Oops. Oh, come on. All right, so because like they're split, one of them's going up and one of them's going down, I'm thinking I've got to have some kind of odd degree. I think it's got to be an odd number because one of them's up, down. Look at these guys down here with the even degree. They're both going, both ends were up or both ends were down, but they're both going the same direction. So because the graph they showed me was kind of split, it's got to be some odd degree. So let's see here. Degree, I'm going to say it's got to be odd. Leading coefficient, let's look at the leading coefficient. Is the right side going up or the right side going down? Let's see. Right side goes up, so that's got to be this odd degree with a positive leading coefficient. It's kind of in this category right here. Odd degree with a positive leading coefficient. So leading coefficient, I'm going to put positive, right? That was my positive sign. All right. I didn't find any specific numbers, but I do know that the degree has to be odd and the leading coefficient has to be positive. The next one, part B, has, sorry, there we go. Go away. Okay. Okay, there we go. Let's see. My leading coefficient in this case, because both ends are going down, let's see, it's got to be, let's see, both, yeah, I think it's got to be like this guy. Both ends are going down. That has degree that's even. All right, so my degree here is even, and the leading coefficient is either positive or negative, and the ones that I was looking at here, these are your negative leading coefficients. All right, so even degree with a negative leading coefficient. All right, so I didn't have to write much about a polynomial. Last bit here, number 4, which of the graphs below matches this function? So let's see if we can know if we can find out the end behavior of this function that they gave us, then I can probably match it because it looks like all these ends are totally different. Actually, B and C look like similar end behavior, but oh, let's supposed to say A. Cross that out. There's your A. So the B and C looks similar, but the A and the D totally different. So let's check and see. I've got, first things first, I've got a degree 4. Okay, so degree here. 4 is an even number. So it's got to be one of these two. And then let's get the leading coefficient. So the leading coefficient is a negative 0.5. I don't care about the 0.5, but it's a negative number. Okay, so with those two put together, it's got to be this kind of end behavior where both ends are going down. So let's look at which ones of these have both ends. Okay, so it looks like A is out, it has both ends going up. D is out, we got one up and one down. I'm supposed to have both ends down. So I'm down to B and C, which at this point, I'm going to try to narrow it down with a specific number. Personally, I think the easiest number to plug in would probably be 0. So here's my x-axis. So if I plug in a 0, this one hits the point 0, 1. And this x-axis looks like it hits the point 0, 0. So let's check this out. Which one should I actually hit? So I'm going to go ahead and plug in a 0 for all my x's. There are multiple numbers you could plug in for your x's. I chose a 0 just because it's easier. Okay, so when I plug in a 0, 0 times whatever is still 0. That's a 0. Another 0 plus 1 is just 1. So I should hit the point 0, 1, which means option B it is. It's not hitting 0, 0. All right, so there we go.